Do you know how pilots fly the aircraft? Do you know how they make it turn? It is not magic. We will show you how. What is flight control? It is the activity of directing the movement of the aircraft. Flight controls are the ones responsible for maneuvering the aircraft on the ground and in the air. Each flight control has its own function. You need to familiarize yourself on the three axes of flight, the flight control systems, the primary flight controls, and secondary flight controls. The three axes of flight. First axis is yaw. Yaw is the left and right movement of the nose. The next is pitch. Pitch is the up and down movement of the nose. Now the roll. Roll is when we bank or turn the aircraft's wings. Let's do the recap. Yaw. Yaw is the left and right movement of the nose. Pitch is the up and down movement of the nose. Roll is when we bank or turn the aircraft's wings. The most basic flight control system designs are mechanical and date back to early aircraft. They operate with a collection of mechanical parts such as rods, cables, pulleys, and sometimes chains to transmit the forces of the flight deck controls to the control surfaces. Rugged, light, and reliable, a cable and pulley flight control system transmits the rotation of the yoke to the rudder, elevator, and ailerons. The elevator for the pitch or the up and down movement of the aircraft. The aileron is responsible for the roll, and the rudder for the left and right movement of the aircraft. So when the pilot rotates the yoke, a sprocket rotates, setting off a series of movements down the length of the steel or stainless steel cable. A bell trunk converts the movement from a cable to the metal rod that articulates the aileron. The rudder and elevator are also cable driven. So here, they are operated by the pedals. One of the advantages of the mechanical flight control system is that you can feel the wind pushing against the control surfaces. This is good for pilot training. The pre-flight inspection calls for manipulating all controls and checking for free cable or pushrod movement.
Time passes by. The aviation develops. That includes the flight controls using the hydromechanical system. The hydromechanical system make the control force required by the pilots manageable and more convenient.
A selector valve rotates through 90 degrees to route hydraulic fluid either side of the piston head to move it back and forth. To pitch the aircraft up, the aircraft pulls back on the control column and the elevator will move up accordingly. When the control column is moved back, the hydraulic fluid is pumped under pressure into the actuating cylinder, forcing the piston backwards and lifting the elevator. When the control column is moved forward, the selector valve directs the fluid onto the other side of the piston pushing it forward and moving the elevator down. Because the piston has a large surface area, it exerts a large force on the elevator mechanism, enabling the elevator to be moved even when the aircraft is flying fast and there is a high airflow over the control surface.
The advantage of hydraulic system makes the pilot easier and lighter to operate the aircraft flight control. If this were operated by cables, it would be extremely difficult for the pilot to operate the plane. The disadvantage of this is if the hydraulic system is ruptured, it will lose its needed pressure and will fail. This will cause the pilot to be unable to control the aircraft with the yoke and rudder. Well, a hydraulic failure is extremely rare.
Now, if you did have lessons, you'd learn to fly in a small plane where the pedals and throttle are likely to be mechanically attached to the engine and parts of the plane. As you can imagine, the bigger the plane, the more complicated all those mechanical parts can be. And the bigger the plane, the heavier all those parts are. That's why most modern large planes, certainly the sort that carry passengers, are run on a system called fly-by-wire. It's not an actual piece of wire. The wire bit is just computers talking to each other. If you had a look in the cockpit of any sort of plane, big or small, whether mechanical or fly-by-wire, many of the instruments would look kind of the same. The flight controls have quite a bit in common too. In all planes, pilots pull back on sticks and throttle levers to control the plane.
In a conventional aeroplane, the pilot pulls mechanical levers to operate a powered hydraulic control system. But with fly-by-wire, the heavyweight gear is replaced by electronics. Now a flight computer carries out the pilot's wishes. The computer keeps the aircraft under precision control during any maneuver, even a simple turn.
So if I want to go to the left, stick to the left. Round to the left.
The flight computer adjusts the wing and the aircraft rolls to the left. Ordinarily, this would cause the A330 to descend. So the computer compensates by increasing engine thrust and pitching the nose up to maintain a steady altitude. The end result? Totally automatic control.
The big difference is that in fly-by-wire planes, the movements of the flight controls are converted to electronic signals transmitted by flight control computers, not cables and cranks. And because less bulky machinery is needed, the plane is a lot lighter, which helps it to get up and away. Fly-by-wire even allows the plane to do things without the pilot having to tell it to, so it makes his or her job a lot easier and safer. After all, computers don't need to sleep, do they? Jumbo jets and large passenger planes need to be in perfect working order all the time. That means a lot of engineers on hand with a lot of tools. Computers help to keep an eye on many of the plane's systems and so makes it easier to know when there's a problem. There's my ride. I'll have to settle for being a passenger for the moment, but one day I'll be in the driving or pilot seat myself. Chucks away!
The primary flight controls are elevators, rudder, and ailerons. We'll go through each one of these now in order. Elevators are located on the back of the aircraft as part of the empennage on the horizontal stabilizer. The empennage is basically from right behind the wings and the remainder of the back of the aircraft. Elevators control pitch of the aircraft. In other words, you can change your angle of attack with these controls as you learned before. By pulling back on the yoke or joystick, this will deflect the elevators up, like so, which creates a bit of drag to push the tail down and the nose up. Conversely, by pushing the nose forward, this deflects the elevators down. This changes the shape of the horizontal stabilizer into a camber that produces much more lift, pushing the tail up and the nose down. Remember, elevators change our pitch. Pull back, we go up. push forward, we go down. The rudder is something that a lot of pilots actually underuse. The rudder is essentially for stable and smooth flight. The rudder is located on the tail as part of the empennage and part of the vertical stabilizer. The rudder controls yaw. If you were to stick a pole right down between the pilots from top to bottom, this is the axis that yaw controls. It doesn't make us turn, it doesn't make us climb up, but it does assist in keeping the aircraft moving forward in a straight line. Without control of the rudder, we'd be hostage to the aircraft pointing the nose where the thrust takes it. Not always a good thing. Ailerons are located on the trailing edge of each wing, usually toward the outer edge. The ailerons control roll. Roll is what gets us to turn. Let's check this out in a right turn and a left turn. When turning right, the right aileron goes up, creating more drag, while the left aileron goes down, creating more lift. Therefore, the right wing dips and the left wing lifts. We are now in a turn. Now, when turning left, the left wing is the one creating drag, therefore the aileron is deflected up, and the right aileron is the one deflected down, creating more lift and lifting the right wing. Usually when you're in a turn, you can let go of the pressure on the ailerons, and the aircraft will generally maintain this turn or slowly return level. This means you need only initiate the turn for the most part.
Flaps are movable devices in an aircraft's wing that modify the wing shape to achieve extra lift and reduce the aircraft's stalling speed during low airspeed operation, such as while taking off or landing. Flaps may come in various forms and shapes, but they commonly extend aft of the trailing edge of the wing. Like this, the total wing area increases and there's higher room for generation of lift. There is a flap lever in the cockpit next to the throttles that can be moved to command either retraction or extension of the trailing edge flaps. The lever has detents in the following positions: up, 1, 2, 5, 10, 15, 25, 30, and 40. When the flap lever is placed in the up position, all trailing edge flaps, leading edge flaps, and leading edge slats are retracted to their normal up position. When the lever is moved from its up detent into any of the other detents, the trailing edge flaps are commanded to the respective position. It takes approximately 38 seconds for the trailing edge flaps to fully extend during normal operation. Slats also are movable devices, however, on the aircraft's leading edge of the wing that change the wing shape to achieve extra lift. They commonly extend forward of the wing's leading edge. Slats are also available to reduce the aircraft's stalling speed during low airspeed and high angle of attack operation. This is done by smoothing airflow in the upper surface of the wing during high angles of attack, therefore generating more lift. Angle of attack is defined as the acute angle between the wing chord line and the relative wind. Slats have a higher field of action in the inboard part of the leading edge because when an aircraft stalls, this is the part of the wing that stalls first. This occurs so that in the initial phases of a stall, the ailerons are still able to provide roll control. Leading edge flaps and slats have two indicator lights in the cockpit, located below the trailing edge flap position indicator. Leading edge flaps extension. This light comes on when all of the leading edge flaps and slats are either partially or fully extended. And leading edge flaps transit. This light comes on when a leading edge flap or slat is not in its commanded position. Spoilers have a contrary effect to flaps and slats. They are panels on the upper surface of a wing that extend upward to disrupt the smooth airflow over the wing. As their name states, they spoil lift generation. When they're extended, immediately behind them a controlled stall is induced, thus creating enormous amounts of drag. During flight, They can be used in one of two ways: to aid roll control by providing significantly higher roll states through uneven extension of all spoilers. This feature is discussed more in depth in the primary flight controls lesson, to allow for steeper rates of descent without a significant increase in airspeed. It's not uncommon to find airliners using flight spoilers to increase their descent rate. When the aircraft is on ground, the spoilers have the following function. As a rule of thumb, the speed at which an aircraft touches down during landing is a few knots higher than the speed at which it would have taken off. This means that when the aircraft touches down, there's still a little bit of available lift in the wings. For this reason, spoilers deploy upon touchdown in order to completely destroy the excess lift and allow for the landing gear to have better adherence to the runway. This allows the wheel brakes to perform better and therefore reduce the stopping distance of the aircraft.
Trim. Trimming, in my opinion, is one of the most important skills an aviator can learn. It is going to be quite difficult to tell you why trimming is so important, so for now we'll learn what trim is, why it is important, and how you can expect to use it while flying. Trim is used to relieve pressures for primarily the elevator, but there may also be separate trim for the rudder and ailerons. The trim tab on the elevator can be seen here. While flying, I generally like to keep my aircraft flyable with my thumb and forefinger. This stable flight condition is only possible by use of a properly trimmed aircraft. In Flight Simulator, you aren't going to be able to feel the forces of the yoke pull the aircraft. You will, however, be able to see what the aircraft is doing in relation to the setting you want. It's much more difficult to trim in Flight Simulator than it is in real life. By trimming the control pressures on the elevator, for example, you won't have to hold the yoke in constant pressure to maintain a desired situation, say an airspeed. Rather, by setting the trim correctly, you can release all pressure on the yoke to where it goes back to neutral, but the aircraft is still in that desired position. This is all thanks to trim. If you don't trim, you are going to have sore muscles and a nice sweat. You've got to learn how to trim. Let's go over some scenarios and we'll look at the correlating trim adjustments that are needed. Say you want to fly straight and level, but the aircraft is pulling you up. By then pushing the trim wheel forward or up, you can trim off the extra pressure needed to stay straight and level. It may take large adjustments at first, and then you can fine-tune from there. Let's say you are climbing at full power, but you want to maintain a certain airspeed without constant pressure on the elevators. Control the yoke by pushing or pulling until you find the exact airspeed you'd like to keep. If during this transition you find that you'll need to start trimming in that direction to make it easier, go ahead and do so. Now, fill the yoke. What pressures are you feeling? Are you pushing the nose down, pulling it up? Adjust as needed so you could let go of the yoke and it would still climb right at that airspeed without any pressure. These are just a few small examples. It's important to note that trim is very important for takeoff, as an incorrectly trimmed aircraft can result in a very dangerous situation. Just place the trim wheel in the green or takeoff area of the wheel during pre-flight or taxi and you'll be set.